Hey, I'm Oscar the intern.
Exactly the same process here that Shanley's doing.
We finally finished installing the electrical distribution backbone in the building.
We're back at the St. James today and we're just coming to double check our template to know that we've got the right radius so we can go back and make our curved mouldings for our ceilings here. So we're going to pop our template and now I'm just going to measure down from the point of the curve down to the straight, so then we know our moulding will be exact and it will fit properly. So 170 down. So now we're back in the main foyer and we're just double checking the same template that we checked upstairs to make sure all the radiuses are the same for all the ceilings down here. And we're looking good.
This is the manufacturer of a 13mm thick fibrous plaster sheet, which is a 3 metre by 1.5. Formula is we put down a face first, which is obviously the surface area. It gives you your nice finish. And then once the face is down, we'll put what we call the backs on. And for this particular size sheet, we're using 32 litres of water in the back and about 3 litres of water in the face. And then obviously we add the powder, and usually the powder is 1 for 2 on ratio. So let's get underway.
So one water to 2 powder? Or
Yeah, 2 powder. Yeah, 1 water to 2 powder.
1 water to 2 powder. Yeah.
And the way we're going to make this sheet is the traditional way that I was shown, which is a pretty old school way.
So it's back in the 1800s, or?
Thank you. Thanks, Steve. Which is my Uncle Tootie back in the 1930s learnt in Onehunga. And for the want of modern technology and everything, the process is pretty much the same. So our faces are like a creamy mix. Size sheet we're going to make here now by 1.5 metre, 13mm. And what we also do is we put on it what we call a couple of rebate strips. So when the sheets are joined together,
There's a rebate.
this is a rebate. So when one sheet goes against the other one, you've got a little recess there that the fibrous plaster can put some plaster tape gauze in to stop it.
Got it.
This
Do they go on the ends as well, or not on the ends?
depends on the client. If you've got a lot of sheets back to back, end to end, sometimes we do put them around the edges. And we can put them no rebates if somebody wants it. Depends on the client and the job. 3 tables. If you're making just sheet, you can usually do between 18 and 24 sheets a day.
Okay.
But then, of course, if you do that every day, there's the odd day where it's going to be a little bit less because you've got to rack and hang them.
Yeah.
And we hang them all in the drying room there, which is a time-consuming job.
Yeah,
because
totally.
they weigh so much. And then the face just gets tossed onto the table like that. Remember, of course, what we're working with is we're working with a casting plaster that sets anything between 7 and 11 minutes. So you don't have a lot of time to muck around. You need to have a good process. And so what we do now is we spread this face out, and what we're looking for is we're just looking for a thin film across the surface of the sheet. Because remember, underneath this is our actual finished product. Okay, so once Shanley finishes that off, my job now is to do what we call mix the backs.
our backs on, it doesn't go straight through.
We clean the buckets, empty it in here, and we always top up the table just with a last little bit of plaster, which is what we use this for.
Now I'm going to give it strength and shoot it with the Romans. Slow way.
So now what we're going to do is we're going to push that, and you're pushing it sort of firmish, making sure it's wet all over, and remembering of course that face that we put down first is already tacked off and setting, so we're not pushing through to that. Once we've got that pushed down, then what we'll do is we'll do what we call turn the edges. We're now going to do the final part of the process, which is we're going to spread the sheet. And these sheets weigh upwards of 85 kilos wet and green like this, and those strings will hold that weight no problem at all on a stainless steel hook. That's how strong the sheets are, even when they're green. What will happen over the next couple of minutes is it'll almost set, and all we'll do is we'll do a final trowel off, which just flattens down any of the fibre hairs that are sitting up, and just giving it a bit more of a nicer appearance.
We've got such a huge, diverse range of tasks that we've got to do at St James. Everything from like fibrous plastering to structural concrete work. And we needed a tool supplier that had a wide range of tools and the quality that could meet our needs to deliver that. So I'm really excited to announce that we've partnered with Milwaukee Tools. We've been building this amazing tool shed with Milwaukee for the last month, and today we had the management come in and check it out to sign off the final product.
Hey, I'm Oscar the intern. This is just an update from last time. We've uncovered about 100 of these patches on this half of the west wall, and so overall for this one side of the building we'll end up with about 200 patches to do, like this one. A lot of the bar is in quite good health. There's only really surface rust, no proper damage to the rebar, which means that we can just treat it with anodes and then cover it back up again. This bar here, the corrosion has gone quite deep into the steel, which means that it's become quite a lot weaker than what it should be. And to fix that, we're going to cut out this entire length, probably about this much, take it out, replace it with ideally the same size, same strength rebar, do a full penetration butt weld at both ends, and it should come out stronger than it is right now, and then we'll carry on with the anodes and then cover it back up again, just like we would with the original bars. The problem we have is that a lot of the concrete came out like this, which is poorly compacted, so there's a lot of voids going through the concrete. So when the water travels, they enter through here a lot quicker than they would somewhere where there's no holes. And when the water travels through, this section here would have looked like that before we uncovered it. And so when the water travels through, it picks up all the chlorides in these rocks, and there's shells somewhere in here, and attaches onto the rebar and rusts it out. First we target these sort of areas because that's, there's almost guaranteed to be quite a lot of corrosion behind it. And then once we get to this point, like here, we see there's quite a bit of damage on some of them, and we'll just take it a bit further up. And if they're still corroded, we'll keep going until we reach an area that's healthy, that's not going to be sort of dangerous to keep.
This is a really good example of one of the issues of deferred maintenance that we're dealing with here at St James. And you know, these windows are somewhere between 80 and 100 years old in this particular bit, and we're currently in the little nibble nook, or the members lounge on the first floor. And that's that, you know, these windows are so decayed that there's actually very little material left to work with and restore. So one of the questions is to what extent we go to with restoration, or do we just replace it with new? And you know, it's not just the windows that are like this. Substantial parts of the building are in similar condition to this. So I guess it's about working through piece by piece and identifying which bits are restorable and which bits we're just going to replace wholesale. We've finally finished installing the electrical distribution backbone in the building, and that comprises of new connections coming in from the street in both the northern and the southern inputs we've got in the building, because we've got 2 electrical inputs, and then new subboards throughout the building which we can then run circuits from. We've converted an old dressing room in the southern basement. What you see up here is our new inputs from the street connecting the mains distribution board to the street network. What you see here is our old stage distribution board that used to provide all the power for the shows essentially happening on stage. And this is our shiny new one. So it's going to be a fully new system from start to finish. We're in the sound tech room at the moment, and this here is the audio distribution board. This is a new subboard we've put into the building. There wasn't originally a subboard here, but just for future proofing we've decided to put one in because it makes running new things easier in the future. And this is the subboard for the first floor lobbies. We're in the northern basement of the building, and this was always really a back of house area for the theatre. And this is our northern input. So this comes in from the street, it's a new connection, and provides power to this area of the building. So the reason we've actually gone with 2 power inputs for the building is the building originally only had 1, and it didn't have sufficient power or electrical capacity to run the larger shows that are running today. So we've essentially doubled the supply into the building, which opens ourselves up to be able to doing more shows. We're in the cavity between the ceiling of the first floor and the seats and the gods, and this is the most awkward subboard that we've installed so far, and this is the subboard for the gods. Installing all these subboards has meant that we've put this electrical backbone throughout the whole building, and essentially it means that in the future, it future-proofs the building. So if we do need to add more power or more capacity in certain areas, we can get in and do that because we've got the mains already there. You can see the difference in the systems that were here and the ones we've put in. So this is the subboard that was for the gods, and that is what we've replaced it with. In order to cater for the electrical demands of modern shows, we've had to increase the power supply into the building. And this here is our new power supply from the street, which we've brought in, and that essentially doubles the supply of power into the building. Another part of the electrical system we've been looking at is some of the architectural lighting and lighting, I guess, features throughout the building. And these amazing cove ceilings were originally light features. So at the moment we've been trialling different options, LED and things like that, to how we're going to light those and to try replicate how they were lit originally.